We are counting down the 10 biggest steam locomotives ever made. These were machines so massive they bent steel, shook the ground, and forced railroads to rewrite the rules of engineering. Forged in fire and fed by coal, they ranged from experimental giants that nearly destroyed their own tracks to powerhouses that pulled entire mountain ranges behind them. Each entry pushed closer to the edge of what iron and coal could achieve. Some were legends, others cautionary tales. Which engine reigned as the ultimate titan of steam? The ranking begins now, with number 10. In 1943, Baldwin Locomotive Works delivered a machine unlike any other, the Southern Pacific AC-12 cab forward. Stretching 123 feet and tipping the scales at nearly 1.2 million pounds, it was built to conquer the suffocating tunnels of the Sierra Nevada. By moving the cab to the very front and placing the firebox at the rear, engineers gave crews a breath of fresh air where others had nearly choked on coal smoke. With 6,000 horsepower, the AC-12 thundered over Donner Pass, hauling wartime freight through mountain storms. Only one survives today, number 4,294, preserved in Sacramento, a testament to ingenuity shaped by necessity as much as ambition. In 1942, the Pennsylvania Railroad unveiled the T1 Duplex, a vision in streamlined steel built for speed and spectacle. Twin sets of driving wheels promised over 6,500 horsepower, aimed at turning the Broadway Limited into a blur across the heartland. But beauty brought trouble. On slick rails, the T1 drivers would spin wildly, sometimes sending showers of sparks and forcing engineers to throttle back. Pennsylvania Railroad maintenance logs from 1946 report repeated wheel slip incidents, with crews quietly modifying controls in hopes of taming the beast. The T1 cut a striking figure, but its elegance often outpaced its grip on the rails. In 1914, the Erie Railroad and Baldwin Locomotive Works unleashed the Triplex, a 28882 engine with 3 sets of driving wheels and a reputation for chaos. On paper, it promised tractive effort beyond anything seen before. In practice, it devoured steam faster than its boilers could provide, starving for power the moment it left the yard. Track crews in Meadville called it the Yard Ripper after a single run snapped couplers and left rails bowed under its weight. The Triplex was a warning. Raw size without balance could turn ambition into a maintenance nightmare. In 1941, the Chesapeake in Ohio unveiled the H8 Allegheny, a 2666 Leviathan built by Lima, tested at over 7,500 horsepower. Its arrival brought more than just power. The first runs cracked bridges on the New River subdivision, forcing emergency repairs and triggering a fine against Lima for exceeding weight guarantees. Inspection telegrams from the time detail frantic overnight work to shore up girders after a single trip. The Allegheny's axle loads were so high that rails had to be replaced, sometimes after only a handful of runs. Here, unmatched horsepower collided with the limits of steel and stone. One survivor, number 1601, now stands silent in the Henry Ford Museum, a monument to the day when ambition outweighed the ground itself. In 1941, the Duluth-Missoub and Iron Range Railroad put the Yellowstone to work, a 2884 Titan built by Alco, stretching nearly 140 feet and weighing in at over 1.2 million pounds. Designed to haul Minnesota iron ore to Lake Superior, these engines routinely pulled 180 car trains, moving more raw tonnage in a single run than most railroads managed in a day. Crews swore you could feel the rails sink beneath her, half an inch some claimed, as the Yellowstone thundered by. With 6,200 horsepower and relentless stamina, she turned the ore lines into a conveyor belt of steel, outhauling anything else on the continent. Norfolk and Western's Y6B, built in 1952, arrived as the last great American compound steam locomotive. With its 2882 wheel arrangement, the Y6B could switch between compound and simple operation, recycling steam through 2 stages for unmatched fuel savings on the flats, then shifting to raw power for mountain grades. This dual system let the Y6B move up to 300 loaded freight cars in a single run, a feat recorded in Norfolk and Western performance logs from the mid-1950s. Engineers praised her for a ride so smooth you could balance a nickel on the throttle. Yet when the throttle opened, she delivered a deep, steady pull that made the rails hum. The Y6B stands as proof that at steam's peak, efficiency and brute strength could ride the same rails, right before the age of the heavy hitters that would shake the ground with every blow. Santa Fe's 210-4 Texas types were not just big, they were notorious for the way they punished the rails. With 10 driving wheels and a rigid frame, the hammer blow from each piston struck down like a sledge, sending shockwaves through the track. Maintenance bulletins from 1940 show rail failure rates nearly tripled after these engines arrived, with impact stresses measured 17% higher than anything Santa Fe had seen before. Crews in Amarillo called them rail breakers, and the name stuck. Track gangs braced for cracked rails and battered joints, sometimes hearing the ties pop and feeling windows shake as a Texas thundered by. The railroad spent heavily on heavier 132-pound rails and denser ties, but the pounding never really stopped. Power came at a cost. Every mile demanded more steel, more wood, and a willingness to let the ground take the beating. In 1944, the Pennsylvania Railroad rolled out the Q2 duplex, a machine that redefined what a rigid-frame locomotive could do. On the test track at Altoona, the Q2 delivered a staggering 7,987 drawbar horsepower, coming closer to 8,000 than any other steam engine of its kind. Unlike articulated giants, the Q2 packed its power into a single unbending frame with two sets of drivers working in tandem beneath its massive boiler. That meant it could haul 7,000-ton freight trains at 70 miles per hour, a feat logged in Pennsylvania Railroad dynamometer records. But all that muscle came with a price. Shop ledgers from 1945 show maintenance costs spiked as crews wrestled with complex valve gear, high-pressure boilers, and the relentless stress of so much force on a single chassis. On the rails, the Q2 was a marvel, proof that sheer horsepower could be contained in one frame, even as the cost of keeping it running threatened to outweigh the benefit. For a brief moment, it stood alone as the king of non-articulated power, just before the final, even larger articulated titans took the crown. Union Pacific's Challenger class arrived in 1936, built by Alco, to answer the call for faster, heavier freight across the Mountain West. At 122 feet long and tipping the scales near 1.1 million pounds, these 4664 articulated engines brought a new standard of power, one that demanded as much from the rails as it did from the crews. Challengers could muscle long trains over the steepest grades, but their weight and speed pressed existing track to the breaking point. On main lines, Union Pacific accelerated upgrades to 132-pound and 136-pound rail, reinforcing the backbone of the overland route to handle the pounding. Engineering memos from the late 1930s detail a wave of capital projects: heavier rails, deeper ballast, and stronger bridges, spurred by the Challenger's relentless force. Yet even with these improvements, lighter branch lines sometimes buckled under the strain, forcing dispatchers to reroute or limit tonnage. The Challenger stood as the last word in mountain steam before something even larger rolled out of the shops, a machine that would redefine what the rails could bear. In 1941, Union Pacific and Alco unveiled the 4884 Big Boy, a locomotive so immense it redefined the limits of steam on American rails. Measuring 132 feet from coupler to coupler and weighing 1.26 million pounds with its tender, the Big Boy was engineered for one purpose: to haul 4,000-ton freights over the steepest grades of the Wasatch Range, unassisted and at speed. Each articulated drive set delivered the force of a small fleet, channeling nearly 6,290 horsepower through 16 massive driving wheels. Otto Jabelmann's design team at Union Pacific pushed Alco to build not just bigger but smarter, balancing brute force with an advanced suspension that let the Big Boy glide at 70 miles per hour, even fully loaded. Crew reports from the 1940s recall the sensation underfoot. As the Big Boy thundered past, Track workers swore they could see spikes walk themselves out of the ties, the ground trembling with every revolution. No other steam locomotive combined such length, weight, and proven hauling muscle. The big boy did the work of 3 engines, earning its place as the undisputed king of the rails. Today, number 4014 stands as the last of its kind still breathing steam, a living monument to the era when American ambition ran on steel, coal, and the will to conquer mountains. Across all 10 giants, one pattern stands out. The pursuit of size always pushed the limits of what steel and earth could bear. These locomotives prove that ambition has a weight, and sometimes the ground itself sets the final boundary. Their legacy is the scale of what endures.